This is a short video lecture that moves into the next one. Let's talk about this. When we talk about stars being far away, current spacecraft tens of thousands of years, hundreds of thousands of years, to the close ones. So we'll see what we do with that. We look up and we see in the night sky stars and we make up patterns. So let's a little review back, right? And different people connected these dots differently, and they had different stories, and they had different names. So the names and the stories don't have any meaning. Right? We have astrology coming out of some of the Greek mythology, right? But there's different astrologies too, right? Chinese, notably, and others. So, but they are what they are. We wonder what they were. No wonder that we, with our standing outside with our sheep, looked up and wondered. I mean, how could we possibly know? Well, we couldn't, as ancient shepherds. We couldn't know. But little by little, slowly, we developed ways of knowing. And so we've come to know how far away these are by breaking down the light. We've come to know how far away, at least close ones are, and then ways of getting farther out and farther out. We've come to know and ways of finding the luminosity, how much light they give off, the temperature based on the color, and the brightest frequency given off, composition. But how do we organize and find what we find from the light, the laws of light, looking at each of these stars? Well, first I want to talk about how far is far. Remember this old thing. If we take that sun we just did, shrink it down to a softball, then 10 of these meters, long steps, you can think yards, 10 yards if you know football, long steps, maybe that's 2 of your steps, so then 20 steps away, here would be to the back wall of the planetarium, would be where Earth would be, right? A grain of sand, 100 across there. Pluto, 30 to 50 AUs, sometimes closer, sometimes further, about 40 AUs out, would then be, Earth is 10 yards away. Pluto would be 4 football fields away. Not even close to the next star. This is Sun. And we try to make sense of these numbers that are so outlandish. Well, where would the next star be? In reality, 4.2 light years away. 1 light year, about 63,000 AU. But if this was Sun, and Earth was at the back wall there, 10 yards away, and Pluto was 4 football fields away, how close then would the next star be? Denver. From San Francisco to Denver, like 1,000 miles. So I just did some rough calculations. So I go 4 football fields away. I go across campus, whatever, and there's Pluto. I got to go from San Francisco Bay Area to Denver to reach the next star. So it's pretty crazy. And I continued out. I don't think I'll go beyond to the center of our Milky Way. So stars are far. Far is far. But we look up, we wonder about these things, and we try to make sense of them. Well, I love this region, of course, though it's out at night more in winter. As we get into spring and summer, it's out during the day. All right. A lot of cultures, a lot of people saw a hunter there. Didn't name him Orion. It's kind of cool though in this region, right? I got the Orion, I got head, shoulders, belt, sword, feet, if you want to do that. Rigel being related to the Arabic for foot. Oh, I didn't put this up. Who's this? So this is kind of cool. Well, let's go through this. Well, this is Betelgeuse, right? Or Betelgeuse. These make the winter triangle, very nice triangle, about 2 fists and a thumb between each of them, 25 degrees, 25 degrees, 25 degrees, procyon. Different colors we see, reddish, orange, orangish, bluish, white, white, and so on. And you can make anything. There is a kind of a dog here that looks kind of like that, if you want to do like that. Dog star. Sirius, we know, apparent magnitude about -1.5. So we look and we watch them all rise in the east, coming over here. And what's so great about this region, here's the Gemini twins, but that's only with the Greek mythology. And what's interesting about the mythology, we'll talk about that over here with Pleiades, is there's actually different stories for the same mythology, but different mythologies, and it's just made up. It's fine. Telling stories is wonderful. But take it literally and don't think that it rules your fate. You do. So, Gemini twins kind of look like twins, right? Bow-legged and long torso, sort of like that. Betelgeuse, I love this region. Look at Betelgeuse. We thought it was going to explode pretty recently because it got bright and dim and bright and dim. It had an interesting behavior that looked, it's going to blow. Oh, it doesn't seem like it's going to blow right now. It's going to blow soon. It's near the end of its life, but that's a long time for humans. So this guy's about to die. Right here in the sword in the middle is really a fuzzy area, which you can see with binoculars. You can start to, but a good telescope, you can see that. You can see it on the internet really well. The Orion Nebula, Messier Object 42, and here stars are being born. Stars are being born. This one's about to die. Here they're being born. Over here, and right about there, here's good old Taurus, the V, with Aldebaran, and kind of long horns, right in that region right there. You can't see it with your naked eye. It's kind of hard to see. Is the Crab Nebula, Messier Object number 1 and 1. It died. It's already exploded. Right? Being born, about to die, died. How cool is that? And the regions of the stars. I mean, you would never see this with your naked eye. You couldn't know. But now you can. Now you can think about this stuff. And you know that astronomers do the hard work. A tax preparer does the hard work of preparing taxes. A chef does the hard work very hard work of cooking. Astronomers do the hard work of breaking down the light, figuring this out. Astronomy and physics. Over here is a little group in the region we call Taurus. And that's a group of, it's a star cluster. M45, Pleiades, 7 sisters. Subaru in Japanese, meaning unity. At least one Native American tribe story was a canoe. So make up your stories. But it's there. And what's interesting, it's a star cluster all formed out of that cloud and together. Similar distance from us, about 400 light years, 410 some light years away. 400 light, that means the light takes 400 years to get to you, and you'll see it. And with your eyes, you might see 6, or you might see 8. For some reason, it's often called the 7 sisters. But really, there's about 800 stars formed out of that cloud, and that's kind of a small cluster. So in this region, it's so rich when we think about what's out there, these stars. Some being born, some about to die, some that have died, some that were born together. We take that light and we break it down. And how do we organize what we find? So we look at each star. Now these are the patterns, right? Or this is where they are. And again, you can make up whatever pattern you want and write your own story. You're free to do that. And I think that'd be cool to give kids just a picture of the dots and let them make up the stories and connect them and see what they see. I think that'd be really cool, right? Really cool. Let them name it whatever they want. It's just as valid. Right? But knowing about the stars requires us to gather the light with telescopes to break that light down and decipher it with laws of light, laws of physics. And so we take each of these, and this is the way they look here, but we're going to chart them. We're going to chart this now in the next video. And we know what we can see. Hertzsprung realized that this is a good way to organize it, and Russell also did, and there's variations. There's variations on this. It's a very useful tool. It helps us organize what we gather. And we're going to see that we're going to chart this. With Wien's law, we can get the temperature. We know that's related to the spectral class. Ooh, you might have forgotten about that, didn't you? And that's related to the temperature. So we'll do this 3 ways. And over here, we'll do the luminosity, not the brightness. We'll do this in detail, L. How much light is giving off, not how bright it looks to our eyes. That doesn't matter, right? We want to know about each star. So each star will have a certain luminosity and a certain temperature, and we'll put it. If it's it'll be there, or where will it be? And what does that mean? What does that tell us? That's what we're going to do in the next video. We're going to think about what would make sense. And things don't always make sense the way we think they would, but there are some things that really can make sense. Because we take the light from each star and put it on her. Now you can take the light, for instance, it's been very fruitful, useful to take the light of the Pleiades and break it down, break the stars down, and study that, study what the stars in Pleiades. But we're going to do like a general sample of stars, where the general idea, where do they get plotted on this HR diagram? What's the temperature? What's the luminosity? What does that tell us? What might that tell us about the size, the stage of life? What might it tell us about the how long it's going to live, how it's going to die? So it's not too bad. It makes sense. Let's do that in the next video.